forward here, so. All right, now, here's where we left off in the other class. Is this one anybody wants to look at?
We did this one and then number 4 as well. Yeah, that would be great.
We'll do this one, because I do want to talk about this one. And then number 4, I might help people individually. Okay? Because we'll have some work on. This is the third packet, the one that says exam 2 on the front.
Are you sure?
Yes.
You actually did the second time.
No, this is the third
Wait, but
packet.
is this my third packet?
That is your third packet.
But
It
this
says
is
exam 2.
The last thing.
It's
Oh.
the very last one.
Well,
Free
thanks
response
for
number 6.
specifying.
Yeah, and in this packet, and they actually don't number this the same either. They do 1 through 28 in the first section, then the other packets started at 29, right? This one starts over again. It does 1 through 17, and then this is the free response we're talking about. This is the free response, so it's the very last page. Okay, but is everybody clear on the different packets, right? I'm sensing some confusion here. The first 2 packets, great big, Riley. The first 2 packets, great big on the front, say sample, right?
Oh, wait.
Sample exam. Okay, so that's sample 1 and sample 2. Those are due on Monday. So before we take the midterm, everybody will hand those in. Okay, sample 1 and sample 2. All right. Those are from a book that was written, a practice book that was written in 2004, 2003, 2004. Okay, this packet is from this white book that was written in 1998. So it's a little old. Okay, now you can tell 1998. Was anybody born? You guys were born.
I'm 95.
I was
Yeah, when I was like 3.
So you guys are like, okay. So, and I was teaching calculus. Yeah, I don't know how time flies. Okay, so now you notice, and I don't know if you did read this, but at the start of the free response section of page 42, it says 6 questions, hour and a half, calculators. In 1998, you could use calculators on all 6 free response questions. But that has changed. Remember what I was saying the other day? The CAS calculators were just starting to come in at that time. And so this problem would definitely be a no calculator problem. Okay? So when you're doing this packet, there is some of that. Matter of fact, we did one in the multiple choice calculator part in the other class that they were telling me they did, and we could look at that one too, that they did with their calculators. I know for a fact that would be a no calculator one now. So it's kind of worth knowing that. Now, if you went ahead and did it with your calculator on this packet, that's fine, because it did say you could. But just understand that on the midterm, it probably will be in the other section. All right, so this is one very much like the one we did the other day with the square root of b stuff. Okay, so it's going to be kind of ugly that way. But I said the more often you see one of those, the better at it you should get. But also what I like about this problem is it brings up some stuff that we really have to start thinking about now when it comes to the chart. You know, when we did the chart, we were pretty simplistic. And we were only dealing with nice, smooth, differentiable functions. We didn't talk much about where the derivative is undefined. Even when we did optimization problems, the derivative being undefined didn't pop up very often. And that's something we have to consider here. And so it's worth, it'd be good to talk about. All right, so here we go. A and B. A says find in terms of A and B. So what do we say that means? They'll be in your answer. A and B will be in your answer. Find where F is increasing. Okay? Now, how do we find where F is increasing? Well, that's where F prime is positive, but what do we find? We do F prime, and you can't just find where set equals 0, right? To find when F prime is positive, you have to find when F prime is 0. And then you do what? Number line, right? That's how you do where is F increasing. You set the derivative equals 0 and do a number line. Then B says find the local max and mins. Well, once we do a number line, won't we have local max and mins? Right? That's on our number line. So that's what we want to do for part A and B. We need a derivative and do a number line. Okay, so here's F up here. And that's ax plus bx to the negative 1. So now we need to do f prime. Well, that would be what? A minus, because we'll bring that down in front, bx to the negative 2, which means a minus b over x to the second. That's our f prime. Right? Now we want to set that equal to 0. So we're going to go a minus b over x squared, and we're going to set that equal to 0. So tell me what I would do to solve that. I could times both sides by x squared. Didn't really think about that, but that's I was going to add this over then times by x squared. It ends up being the same. So this would end up being ax squared minus b equals 0. Would that be right? Times both sides by x squared right now. That's a good strategy whenever you have a fraction like that to clear out that fraction. So then we get ax squared equals b. We get x squared equals b over a. And x would equal what? Plus or minus square root of b over a. Okay, so now we do what with that? Put it on our number line. So we got negative square root b over a. Right? Now, here's where, and actually I helped some people with this one this morning, and I missed this myself, because we haven't been doing it for a while, and I should have known that. I should have seen it, not until we got later in the problem and I realized what we had screwed up. And so you may not have noticed this either. So now we're at this point, and what do? We need to put stuff in between. What would be in between here? 0. What would be over here? Yeah, remember what we talked about the other day? You can't square that. You can't say b over a is bigger than square root of b over a. It might be small when you square it. So put a 2 in front of it. Over here, put a negative 2 over square root of b over a. So put those numbers there. Now, here's when I realized, well, actually, I didn't even realize it yet at this point this morning. So we go in here, we put our 0 back into f prime, right? This is an f prime number line. So we're going to put our 0 back into f prime. Now, where are we going to put it? In for x. What happens when you put 0 in for x? It's undefined. So this morning I scribbled out and tried something else, but I should have realized, oh, wait, something strange is happening here. F prime undefined. What happens when f prime is undefined, or what could happen? We could have a local max. See, in our chart, we say that f prime equals 0 is where we look for local max. Well, yeah, in the early days when we didn't have any of these ugly-looking functions, that's what happened. But we also have to consider when f prime is undefined. So when we look at f prime right here, it's undefined when x is 0. So I should have included 0 as one of the points on my number line, as a possible local max min point. So I need to put another dash on my number line, and I've got to consider 0. Because f prime, that could be a local max or min. All right, so now I need to pick some numbers. So what would be a number in between here? How about 1/2 square root b over a? And in here would be negative 1/2 square root b over a. All right, so now let's go to the far right side and let's put that one in first. So we're going to take this and we're going to put it into f prime, right? So what would I have? I'd have a minus b over this squared, right? Okay, so what would that be? Well, it'd be a minus b over 4 times b over a. That's nice. When I square it, the square root's gone. So that'd be a 4b over a, right? Oops, 4b over a. That's a 4. That's 4. 4b over a. So how do I do that? What do I do with that? invert and multiply. So I've got, what I'll have here is b times a over 4b. So I'll take this 4b over a on the bottom, I'll invert it and multiply it times the top. What happens there? The b's cancel. Now, a lot of algebra, yes. A lot of kind of ugly algebra, and that happens sometimes. I'll be honest, in recent years, I don't think they've had as much of this kind of algebra as they used to. Okay? But it doesn't mean there won't be some of this that you have to do. This problem's especially, because then they ask you for the local max min, you know, and there's more to do. But anyway, what's a minus 1/4 a? 3/4 a, and we know that a is positive, so 3/4 a is going to be positive, so we know that's positive. So now what about over here with this -2? When we plug that in, that'll be negative, won't we get the same thing? Because we're going to square it, so the negative's not going to matter. So that's nice, that saves us a little work, so that's going to be positive. Okay, so now let's do the same thing with the 1/2 square root b over a. We get a minus b over, and then 1/2 square root b over a all squared. So that'd be a minus b over, what do we get when we square that? 1/4 b over a, which would essentially be b over 4a. Now we invert and multiply. We have a minus b times, what, 4a over b? Right, invert and multiply. And the b's cancel again. We have a minus 4a, which is negative 3a, which is, since a is positive, we know that's negative. And when when we put that one in, the same thing's going to happen, and that's negative. So it turns out that our 0 was not that, but it might. Okay, so really, so if you're looking at that, saying, God, I never could have got all that algebra all through that. Now remember, there's partial credit. I mean, you get a point for doing this, a point for doing that. You get a point for doing this derivative, right? Setting it equals 0. I don't think that's all bad right there. There's probably at least a point there. Okay, so you get some stuff there, right? Hopefully we get to the point where at least you don't look at one like this and just don't do anything. Just draw a blank and not even write down anything. Okay, but yeah, it might have been pretty tough to get through all that algebra if that was on the test Monday or Tuesday's actually the no calculus. All right, so there we got that. So basically A is, where's it increasing? That'd be negative infinity to negative root b over a, and then from root b over a to infinity. That would be your answer essentially to part A. Where is f increasing? Because the number line is positive in those places. Okay, local max and min points. It says find the coordinates. Well, local max would be this first one. Now how are you going to find the coordinate? That's the x coordinate. How are you going to find the y? Plug it into the original. Now that's going to be kind of ugly too. Okay, and you look up in the answer book and it shows how you simplify it. That's just a bunch more algebra that I wouldn't worry a whole lot about. I mean, you should look at it, try it, whatever. But that's been enough of algebra probably for one point. I would think on most problems you're going to run into. Okay, but that's how you would do part B. Just, you got your local max, here's your local min, plug those back to the original, simplify, get the y coordinates goes with it. Now I want to talk about the concave up part. Okay, so let's go to part C. Where are you going to look for concave up? Second derivative is positive. So let's see, what was our first derivative? It was bx to the negative 2. Okay, so f double prime. Now, how are you going to find when f double prime is positive? Find out when it's 0. Same thing we just got to do. You're going to find when the second derivative is 0 and do a number on it, right? And then the next question is inflection point, which again is going to go along with concavity. So we need to do f double prime. So tell me what f double prime would be here. Positive 2b x to the negative 3, which would be 2b over x cubed. Now we're going to want to set that equal to 0. Right? So any ideas on that, Deb? Where is that going to equal 0? Okay, now a couple things. Number one, some people would think, hey, multiply x cubed over to this side. Well, what happens? It's gone. And you get 2b equals 0, but what do we know about b? It's positive. It's greater than 0. So b can't be 0, right? But I like what Tim said. Anytime a fraction is 0, it's when the top is 0. When is the top 0 here? Never, right? So this is never 0. So does that mean the graph's never concave up? No, we have to do the same thing with inflection points that we just talked about here. Remember, the second derivative 0 is a possible inflection point, but we also have to consider when the second derivative is undefined, just like we did with first derivative. So where's the second derivative defined? X is 0. So we need to do a number line here, an f double prime number line, with x being 0. Because that's when f double prime is undefined. We still could have a change of concavity at that place. So now this is easier because we can just put in numbers like -1 and 1 here. And so we go back up to our f double prime, put in a -1, what do you get? You get negative on the bottom and positive on the top, so that's negative. Put a 1 in, you get positive on top over 1, that's positive. So to answer part C, where is the graph concave up? Zero to infinity, right? When it's greater than 0. Now, anytime you do these intervals for increasing, decreasing, concave up, concave down, always do open brackets, okay? Open parentheses. All right? So from 0 to infinity, it's concave up. So now question D. Find any inflection points. Where's the inflection point? No. Yeah, not x equals 0. Sure seems like it. It's always been that way in the past. This says the graph is concave down, then it's concave up, right? You have to have an inflection point if you have a change of concavity. It's undefined. Think about this. Here's the example that I give you. Just because the graph changes concavity does not mean there's an inflection point. And I'll give you this example right here. What's the concavity over here? Concave down. Over here? Concave up. Is there an inflection point? No. You can't have an inflection point if there's no point, right? There's no point where it changes concavity. Because 0 in the original is not because it was undefined here. That's not it. It's because 0 was undefined in the original, right? You could get a second derivative where it's undefined at 0, the second derivative, but it is defined in the original, and you might have an inflection point. But you can't have an inflection point at a place where the original function doesn't have a point. Okay? Now, let me give you another example. Same thing with local max min. If I gave you an f prime number line that looked like that, what would you read into that right there? You would read into that local max, right? When you look at an f prime number line like that, you think that's a local max. Well, look at this graph right here. Wouldn't this graph have that number line? This graph is increasing, and then it's decreasing, but there's no local max, right? Because at that place where it switches from increasing, decreasing, there's no point. So that it's not a local max there. So again, when we bring in this idea of where the first derivative is undefined or the second derivative is undefined, we got to be careful about what the number line is saying. So this problem does not have an inflection point, even though there's a change in concavity, because it would be something similar to this. Concave down, switching to concave up at 0, but 0 is not a point in the problem, so it can't be an inflection point. So that's why there are no inflection points. Okay? So that's tricky. What I like about this problem is it really helped us review all these concepts about number lines and local max and min, inflection points and all that stuff, but also brought in some of the technical points that we've skipped over throughout the year because we wanted to make sure we had the basics of it down. But now, hopefully, we have that. Now we can get into these. Okay? And it helps us review those concepts. Okay. So we'll leave number 4 for individual work, and I can help you with that. But I will tell you this about number 4. The secret, one of the secrets to it is drawing this is R. And what could you tell me about this little triangle here? It's a right triangle. What else could you tell me about it? This is a square, remember. This side is X.
That's 1/2 X.
Wouldn't this be half X? And over here be half X as well? Because in a square, there would be that symmetry. This line here would divide that in half. Okay, each of those sides in half. That's going to make an isosceles triangle there. That allows you to connect R to X, which is going to allow you to connect the square and the circle equation. That's where you can solve, and kind of like in a cone, we would get the height and the radius, and we'd be able to solve one for the other. That's going to help you a lot. Okay, so once you get into it, then if you've got some other questions, okay. How about back into the multiple choice? Anybody?
11.
Which 11?
Calculator now.
Yes. This was the other, I did want to do this one too, so I'm glad you said this one. This is one that we could do one of two ways. I'm guessing you guys picked the longer way. I mean, it's not a lot longer. They're pretty close. There's no way I don't think you would have thought of the other way. If you looked in the book, you probably saw what they did and said, how in the world did they get that? And it's because of this notation we haven't talked a lot about. Now, the reason we haven't is because the way they did it in the book, I think that's how they did it in the answer book, only works on problems that kind of look like this. So we haven't really talked about it. It's not that useful. But it is kind of cool to see once we've learned this stuff. So I'm guessing most of you would have tried to do what? Now, first of all, let me back up. They want to know the derivative at E. You can't plug E in right away, right? You got to do the derivative first, then you plug E in. Okay, that's first of all. So tell me what you're going to try here.
Y equals sine u. Substitute u into that, and substitute v into that, and end up with sine of parentheses ln x minus 1 over ln x.
Right. That would be the way I would think most people would think about doing it. A bunch of substitution. V is ln x, so then let's put that in for v. So we get ln x minus 1 over ln x, and then let's put that in for u, and so we end up getting this big mess of a thing, right? And then do the derivative. Then do the derivative. And then plug an e in for x. Okay, so that's how I think most people would attack this one. All right? So let's practice that because we need some practice with derivatives. So we start on the outside. Cosine. Inside, leave it alone. Times derivative of the inside, which would be derivative of ln x is 1 over x. And then we got this guy. Now this would be ln x to the negative 1, right? Wouldn't you have to do it that way? No. 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 You can't, no. You can't just do the derivative of a bottom. You know what I mean? You know what I'm saying? I mean, that in other words, if it was, I don't think you would think it is, but if you had 3 over x squared, that's not 3 over 2x. That's what you just did there, right? 3 over x squared, we would write 3x to the negative 2, right? And then we bring the negative 2 down and do the power, right? So there's no rule we have that says, hey, just take the bottom thing and do the derivative. Okay? So that's why we can't do that thing. Okay? What we do is we make an ln x to the negative 1, right? And so then what? You bring the negative 1 down. You leave the ln x alone to the negative 2 times 1 over x. Now that would simplify a little bit here. This negative power would go to the bottom. So we'd have negative 1 over ln x all squared. And then this 1 over x. Wouldn't we have something like that? See what I mean? A negative power would flip it down. So this whole thing would be negative 1 over x times ln x squared. Seeing that? See, this is a classic one where the gateway test doing, if you go this route, doing it like the, why the gateway test was so important, doing this derivative. Now what? Well, of course, this would turn into plus. Now we put an E. Now it's nice that E is going to be pretty easy to put in, right? Because ln E is what? ln E is 1. So what we got here is ln E, that's 1. ln E, that's 1. 1 over 1, 1. 1 minus 1 is, so this whole thing is just cosine 0. And then in the parentheses here, we have 1 over E plus, and then what about this one? ln E is 1, squared is 1, and then x we said was, we're putting an E in for x, right? So that's just another 1 over E. So the whole thing just ends up being that. So we get the derivative right, which of course is the whole problem. Cosine of 0 is 1, and then 1 over E plus 1 over E, 2 over E. So, right? Now, let me show you another way. Now, like I said, this only really comes in handy in a problem that's written like this. So it's one of those things, again, that if you can remember it, great, If not, that's why 60% is a really good grade. I mean, that happens. Yes?
So would you do like the cosine of x minus 4
Right.
well, it says like 1 over b prime.
Oh. Tim, see, you weren't alone. I swear, unless my memory's fading, I don't think anybody in other years has ever noticed this, and now you're the second one. Sam, okay, probably other years, but nobody wanted to admit it. And I'm good for you guys for admitting it. What is that right there? Comma. Okay, so now, so Steve, did you think that?
No.
Okay, all right. That'd have been a great chance. That'd have been a great chance for you to get off the hook. Because if you thought that was v prime, then that would be 1 over x. So you were thinking it's 1 over x. Okay. I tried to let you off the hook, Steve. All right. So, yeah, it's a comma. Yeah, it's a comma. So, okay, Tim, you're off the hook. I was telling you this morning, I was telling Tim, nobody's ever thought that was prime. Okay. So, you recruited people to say that, didn't you? All right. So here's the other way. Now, hopefully, you'll kind of appreciate this a little bit and think, oh, that's kind of slick with this notation, this dy dx. All right. When you've got these different things. Now, we're supposed to find dy dx. I want to look at it just a little differently. What if I did the derivative of this thing with respect to u? Right? Well, how would I write that here? dy du, right? Derivative of this with respect to u. Now, what would that be? Cosine u. Would you tack on a u prime? No. Very good, because we're doing it with respect to u. The u prime just be du, what you want. Okay. Now, what if I then multiplied that by the derivative of this thing? That would be du dv. Right? Now, what would that be? Well, the derivative of this with respect to v would be what? 1 minus, oh, careful. 1 over v would be v to the negative 1. So that would be negative 1 v to the negative second, right? Which would be negative 1 over v squared. So this would be negative 1 over v squared. And those would turn into plus, right? And then, what if I multiplied that times this? That would be dv dx, which would be what? What's the derivative of v with respect to x? 1 over x. Now look at this lineup. dy du times du dv times dv dx. Wouldn't that give you dy dx? It would. It's really the chain rule. It's really Leibniz notation for the chain rule. It's the derivative of, because this is on the inside and this is on the inside of that. It's a derivative times the derivative inside times the derivative inside. That's really the chain rule is what it is. Okay? Well, so what would you have? Now we're supposed to plug an E in for x. So right here we plug in an E. Now here we need to plug in a V. How in the world, hint, 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 how in the world could we get a V if all we know that E is x? Yeah, V is ln x. So couldn't we put an E in there for x? So V would be 1. Oh, okay, V is just 1. So 1 plus 1 is 2. Okay, and how would we know what U is? Oh, we know V is, we just said V is 1. 1 minus 1 is 0, so U is 0. So this is cosine of 0, which we know is 1. And there it is, 2 over E. So that's kind of neat, and it's a different way of looking at that and avoiding all of that messy stuff. But who would have thought of it? And like I said, we've seen it now, so if you see a problem like that again, you could use it. Okay, we didn't really talk about it earlier when we were doing chain rule because it just isn't that practical for problems we normally run into. Okay? But again, if we get the concept of dy dx and chain rule and all that stuff, seeing it once, you're like, oh, okay, yeah, that makes sense. All right. So there's 11. One more maybe.
Can we go to packet 4?
Because what?
Do we want to stay at packet 3?
No, I don't care.
Do you look at,
Anybody else care?
7 packet 4?
Yes. That was certainly one that we were going to have to talk about at some point. Yes, the new packet from yesterday that was on my desk yesterday. Anybody else? No. Just come in right in the middle of class. I'm sure we won't be done. Or I'm sure we'll be done.
So Natalia's still getting stuff.
We don't.
This is it,
It's not
right?
like your block where you have to go to the pit stop in the middle of the period.
You know, a little bored.
That's what I was doing. You got the pit stop.
We just done the fun and games in that class, wasn't it, last year? It's all we ever did, fun and games.
Yeah, it was always fun. Now this is just like,
Kind of set the bar high. Did that sound okay? Did you read it yet? What are you doing?
He would like you to not bother. Can you see?
Work it back to me, and then I'm gonna sign it, I'll send it to you, and tell me if I need to change it. See ya. Love you, bye.
Love you, bye.
Aww.
All right.
why? We'd do it over the fourth.
Oh, I did ask her what size. So yeah, I need. You're right. I'm good. All right, here we go.
Right after we do this call.
G. Okay. So we got this here. All right. Now, what in the world is going on with this one? This again, we're picking out a lot of these problems. We're supposed to find G prime of x. So, I mean, that's kind of a hint. G prime. This has got to have something to do with G prime, right? But again, this is another one of those questions that you go, what in the world is going on? One of that 40% that you could miss and still get an A. All right. So, but seriously, does this look like anything you've seen before on the left side? No, come on.
Yes.
Well,
yeah.
It doesn't it look like this a little bit? Not at all. Oh, it does too. The left side,
I don't know what you're seeing.
right here. The definition of the derivative. Okay. What's that? I'm not smelling what you're stepping. Okay. So this is x. So this would be like this, except x is a. So x and a are like interchangeable here, and b would be like h. Okay. Now, there's a little bit missing here.
Dan!
Oh, just
Dan!
Would you divide by
what?
I'm not gonna eat in your class. Sorry.
Hi, Dayton.
Sorry, Mr.
Oh yeah, I bet you are. If you'd have brought some for me, if you didn't,
I still have same
you,
scholarship.
you had the scholarship meeting. See, I let my class out a little early.
You want me to go give
Yeah.
him his card?
Yeah, give that to Mrs. Clark. Perfect.
Bye, Dayton.
That's true. I let my class out a little early so they could eat. Okay. Come on in, Macy. Yeah, just join the party.
Bye, Macy.
All right, so where was I? A is basically the same as X. B is basically the same as H. Now, it looks like the definition of derivative, but it's missing a couple things. What does this normally have on it? It's got an H underneath it. Well, in our problem, that'd be like having a B underneath it, right? So let's take this side divided by B, and let's take this side divided by B. Okay? Now, what's the right side divided by B? 4A plus 2B. All right, now, we need a new color. Yeah, let's,
Yellow.
yeah, I gotta be able to see it. How about a little purple? All right, now, what else is this missing? What else is this missing? The limit as, oh no, as H approaches 0. So in our problem, that would be the B. So we need to do this as B approaches 0, which means we need to do this side as B approaches 0. What would this side be as B approaches 0? 4A, because the 2B would go away. Okay? So what we just found was G prime of A, right? Because this over here is G prime of X, right? This is the definition of the derivative. So this thing is G prime of X, but we said X and A were kind of interchangeable in this problem. So what we did over here was G prime of A. So G prime of A is 4A. What's G prime of X? 4X. Now, yes, again, another one of those problems that how would you have thought of that? Maybe a little bit, but now you see it. But yeah, what would have been the trigger in that? You look at this, you notice that they asked for G prime of X, so somehow you're trying to connect this to derivative. And then the idea is that this would make you think of the f of x plus h thing. Now, would you be known to go, I don't know. But that's what it was about. That's what it was about. Okay? All right. So I want to give you some more work time. Tomorrow I'll answer more questions. We'll see. I might have some other free response ones I wanted to try, but it just might be more work time too. So, ask more questions about exam 2 if you need. You were supposed to kind of finish exam 2, but obviously you might ask more questions in exam 2, so you can ask about those. Come ask me, work together. Or start on the last packet and get working on that. The rest of the time is yours to work. Andy. No, I'm saying not saying go to the pitch. What you need to do in the future is make arrangements like Sam to have someone deliver something for the pit stop.
That's somewhat what I did.
What is it? Number what?
5.
That's
It's kind of what? Like number 9?
Yeah, that's the same thing.
Oh, really? But just a smaller version? Oh, okay. Well, that's good. Yeah.
It's cheese.
Number 9 is
cheese.
I love it. It's so good though.
What's that?
Slim
You can
Six.
get it if you want.
Slim 6?
It's cheese.
He can go run.
Just order it.
He's still
I said no.
My job. Hey, you buy
So,
it.
be curious to see what else he bought with it. Jimmy John's used to deliver to school, but I don't think they will.
They don't let me to
The
school.
school, that's what I mean, the school won't let them. Yeah,
No, you can deliver to outside. They can't come in the building.
but they'll deliver outside to the parking lot.
Yeah.
So
Okay,
just order one now, you have to walk it off.
Lucas, you have more things to do.
I have important things to do, yes.
It hurts.